really brilliant to have you here. My name is Lisen Schultz. I'm from the Stockholm Resilience Centre, and I will moderate this dialogue on water and climate change. And I'm very honored to have with me 3 fantastic panelists. Please come on stage and welcome Julian Dowdeswell, glaciologist, Stephen Chu, Nobel Laureate, and Johan Rockström, environmental scientist. Please have a seat. And now we will move from the freshwater into this vast topic of climate change that all three of you are heavily engaged in this field. But I would like you to first paint that picture of how water and climate change actually are connected. Maybe I can begin with you, Stephen.
Well, it's actually, where do I begin with that? It's connected in so many ways. A warmer climate means glaciers melt. Glaciers melting changes Atlantic currents and the south-going current, which means the Antarctica will be melting faster and faster runoff because the grounding line is disappearing. Warmer climate means more evaporation, but it's not going to come as water for everyone everywhere. It's a rich get richer and the poor get poorer. So in wet places at wet times, there's more, and dry places, dry times, there's even predictions there'll be less. So these things get exaggerated, and we're expecting many more downpours at the wrong times, not during growing seasons, but in things that actually dissipate the snowmelt. So it's everywhere that we see these repercussions.
Yeah. Johan, do you want to finish?
No, I could take on there. I mean, I think it's important for us to recognize that, I have a hydrologist colleague who often reminds me that if mitigation is about gases, adaptation is about water, which is a way to say that victim number 1 of climate change is water. It's either too much or too little at the wrong time. And that's exactly what Stephen is pointing at here. But the second issue that I think is important for us as a water community also to embed in our thinking is that water is the bloodstream of the biosphere, and the biosphere is the carbon sink on the planet. So if we don't have functioning ecosystems, which fundamentally can only exist if the hydrological cycle operates and the whole photosynthesis and the capturing of carbon and the release of carbon, without that we don't have neither vegetation, nor animals, nor microbes, nor carbon in the soils. We have 600 gigatons of carbon in the 50 centimeter top layer of soils. Mull in Swedish. Now, how do you get that? Well, you get it only if you have water, because it's only through the water cycle and the photosynthesis interacting that you can build up that organic carbon in the soil. So, of course, water is the fundamental prerequisite for having a stable, resilient Earth system.
Well, and what is the role of the polar regions in all of this?
Well, when I started doing polar research almost 40 years ago, the polar regions were really regarded as being interesting, but a little quirky. Why were the polar regions really of relevance, interesting? And people said, well, why hasn't this chap got a beard? He can't have gone to the polar regions. But today, there's a very strong recognition that the polar regions are major drivers of the global ocean circulation through the formation or lack of formation of sea ice in a world which is warming, the generation of dense bottom water, and the way that feeds into currents that drive the North Atlantic circulation, for example. And in the same way, the glaciers and ice sheets, the Antarctic ice sheet, the Greenland ice sheet, and the large ice masses on the mountain areas of the world, are almost all, with the exception of the East Antarctic ice sheet, melting rather rapidly. And that, of course, is one of the 2 major decadal level controls on global sea level change.
I mean, I think it's good to remind us that when we are in deep ice age, which we were like 20,000 years back, we have 100 meters lower sea level on planet Earth. So, I mean, Greenland and the Antarctica holds over 100 meters of sea level potential just in the ice. I mean, these are big dynamics.
And also to remember that in a world 1 degree warmer than today on average, the sea level was 6 to 9 meters higher than it is today. As a matter of history record, not climate models. 6 to 9 meters, well, 10 meters, 10% of the population of the Earth lives within 10 meters of sea level. And so the UN goal is to stay to 6 to 9 meters.
and we were just chatting about this walking in here, Steve and I, that, it's really important to remember that 1 degree Celsius is several meters sea level rise. 2 degrees Celsius, the last time we were there, 130,000 years back, we know was more than 8 meters sea level rise, again, based on observations, not models. And of course, that won't happen overnight. It will happen over perhaps 2, 3, 4 centuries. But is that a long time? We asked ourselves. Because after all, we depend on, for example, religious beliefs and scriptures that were more than 2,000 years old. So the question is, what moral responsibility do we have for a livable planet, not over the next 50 years, but even over the next 300 years?
Yes.
And when do we press the on button when we irreversibly commit the Arctic and Greenland and the Antarctica to melting? That might be very soon, even though the 8 meters may play out over periods that the economy, for example, is completely unable to capture through discount rates.
That actually brings us a bit into one of the Nobel prizes that, or prizes in the memory of Nobel that was awarded this year to an economist who has been able to bring in the climate into economic models in a way, which is a big breakthrough for economy, but comes to a different answer about what is a reasonable warming. Any comments on that?
Well, let me begin with that. And so Bill Nordhaus has actually come along, who's the person you're speaking about, has come a long way, but still there's a little bit of a difference but fundamentally it's a cost-benefit analysis. And in that cost-benefit analysis, there's something called a discount rate. If you take $1 today and spend it on something, or you spend it 100 years from today, it would be the dollar would grow and your economy would be stronger and you would have more to spend. And so the issue is, what discount rate should you choose? Traditional discount rates, 30, 20, 30, 40-year business cycle times, actually discount virtually everything to zero in 30 or 40 years. There is no experience that goes beyond 1 century. And so this is the fundamental problem, that if you're baking in something, and some glacier experts think that already the commitment of the runoff of glaciers, because the grounding line friction that flows beneath the sea level has been eroded back, so these glaciers are running off, now some of them at 1 kilometer per year, it's already committed. Even if you hold the temperature the same, they run off. It's like an avalanche.
Yeah. I think what we're saying is that the world doesn't necessarily modify in this kind of way. It's a very thresholdy world, right. And a lot of the environmental thresholds are coming together. And the grounding line of ice sheets is one very large example of that. The grounding line of ice sheets is where they become decoupled from the seafloor. And the problem is with Antarctica that the seafloor actually becomes deeper as you go towards the center of the continent. And that means that there are big buoyancy problems. And if you start off unpinning the ice from a certain point, it will go back and back and back into deeper water. And this is a threshold vulnerability.
But going back to the original question, there is no discount rate for 100 years from today. It all discounts to zero. So if you care about what happens 100 years from today, the traditional economists will say, no, whatever you spend today is valueless 100 years from today. And so this is something new in society.
Which in simple words means that if you care about the future, these models don't work.
Another way
just
of saying
simple,
that.
just kind of putting it a bit to the point. But that aside, let me just also add then that, like all of us, I would say here, we have great respects to the enormous contributions that Bill Nordhaus has done, the #1 established economist to integrated climate in macroeconomic analysis. He was actually already in the 70s a person who warned us that going beyond 2 degrees Celsius was dangerous. He's a person who's really taken this field very far. I'm today heading an institute that builds very much on Bill Nordhaus' integrated assessment modeling work. But let me just share you one take that I have on his science, which I think is a reminder of the transformation we're facing. So in his latest runs of the DICE model, he shows that the most cost-effective temperature, if you do apply the kind of conventional macroeconomic analysis on costs and discount rates, is 3.5 degrees Celsius.
Right.
Well, if you add up all the national determined contributions of all the countries in the world from Paris, it leads to what? 3.5 degrees. Surprise, surprise. Can this be a coincidence? Could it be a coincidence that when countries put their business as usual pathway, it takes us to 3.5, and when Bill Nordhaus applies the business as usual macroeconomics, it leads to 3.5? I think this is a proof that the economy doesn't work. So I think he's putting a lot of evidence that we need to shift gear into a new way of thinking. And one of the thinkings is that you need a price on carbon, which Bill Nordhaus himself says is needed. So I think it's also a proof of the limitations of our macroeconomic analysis. And I would say it goes really back to Sweden here, because it means that what we call in Swedish samhällsekonomisk konsekvensanalys has great limitations. Has great limitations.
Although I don't think that Bill Nordhaus actually thinks what he was doing. He thinks this is the best, lowest cost solution, from what I read of
I'm taking a very positive take on his research.
But I think I'd like to come back to this notion of tipping points and thresholds, because that's also, I think, something that's hard to put into these models, and that's one of the reasons why it looks as if 3.5 degrees would be a reasonable warming, because then you're not really bringing in the tipping points of Antarctica, the tipping point of coral reefs, and other tipping points in the Earth system that you have been able to point out.
But if you look at his book, there's an asterisk in his book that says, I am not putting in any tipping points. If there are tipping points, all bets are off.
Yes.
But these asterisks need to be watched very carefully. The devil is in the detail, as we say. And the Intergovernmental Panel on Climate Change report has exactly the same asterisks to do with its prediction. The last prediction, the new one is coming out shortly, its last prediction of global sea level, which was actually between 0.2, only 0.2. We don't think 0.2 is anywhere near what will happen. It's going to be far more than that. 0.2 and 0.8 of a metre by 2100. Now, why is that? The asterisk says, but actually, we are not counting anything to do with possible thresholds that I just described to do with grounding line retreat, because we can model them at the moment so poorly. So this is the sort of challenge that even within the glaciological community we have, is to model those kind of thresholds where there is ice, where there is ocean, and where there is atmosphere all involved. We are finding it very, very difficult to do that. A lot of what we need to know is hidden beneath 2 or 3 kilometres of ice. It's very difficult to see what's going on at that interface. So we can't even do that yet. So putting all these things together in economic models seems to me to be very difficult.
And this is ignoring the tipping point of the methane in the frozen tundra, which is a very serious one. And then you say, well, we're going to ignore it, even though we think if you wild guess at 3.5 degrees, reasonably probable that some methane comes out. Lots of methane comes out. The danger of that is once the methane starts to come out and further warms, actually, no matter what humans do after that, the greenhouse gas emissions from just the methane will take you the rest of the way to the usual state of the planet, which was 5 and 10, 20 degrees warmer. This is the history of our planet.
So given this, you study these systems every day and you see these tipping points coming, how worried are you about the future?
I'm scared to death.
Scared to death, Julian?
Yeah, I'm pretty worried. If you look at the changes that have gone on just in the last 10 or 15 years in Arctic sea ice, it's a complete revolution in the nature of the Arctic and how we can access it and so on. It's a huge change. Of course, the Arctic is almost unarguably the most sensitive part of the global climate system, but that is very scary, I think.
And Johan, are you worried?
Well, if Stephen is dead scared, then I'm dead scared as well.
Yeah.
Well, I'm alive but scared.
No, but I'd like to kind of qualify my statement slightly, which is that if I'm not dead scared purely on natural science. I would say that the natural science today shows that despite all the stress that we have posed on the Earth system and all the unsustainable hockey stick patterns we have seen over the last 50 years, not only on climate but also in the biosphere, we still live on a reasonably resilient planet. It still has dominated by negative feedbacks. The oceans still take up heat. We have still carbon sequestration occurring. We don't have the massive release of methane. We have ice melt, but it hasn't collapsed to a point where we can say yet. So
negative feedback means that it's actually dampening
cooling feedback.
So it's positive for us.
So you could argue that natural scientifically, the window is still, but barely, but still open to be able to veer below 2 degrees Celsius and stay within a manageable interglacial state. The nervousness arises when you look at the inertia of our inability to act. And I think that when you put that together, I think that's what makes, I get very nervous when we see what's happening in a world today where we have 2 years to bend the global curve of emissions, and we need to cut emissions by half over the next 12 years. We know we can do it, we know we must do it, but will we do it? And I think that is where the real nervousness arises. Do you agree to that? That it's not purely a natural science scare in a way?
I agree. To a little bit of more optimism, the technology is advancing very, very rapidly.
Exactly.
And so there are good things on the horizon, and more appreciation of how this connected system can be made to have better solutions and much better technical solutions. But the window is closing. To get to not the 1.5 degree, but the 2 degree goal, virtually every scenario there says that by 2080, roughly, the entire greenhouse gas emissions, carbon emissions of the world, including agriculture, including processed heat, including transportation, as well as electricity generation, everything has to go negative for the entire world. So that's the challenge. It has to be negative, meaning we can't not only stop producing carbon dioxide and all the other greenhouse gases, we actually have to be sucking it from the atmosphere in order to get 2 degrees.
And I think from that big realization, I mean, you all three of you are scientists who have also moved more into having an impact on society. And Stephen, you even were in government under Obama. And so in this work that you all are doing, what gives you hope, and where do you see inspiring action being taken on these challenges for humanity, on water and climate?
Well, I mean, I learned this from my PhD thesis advisor. It's not too late until you're dead. But he was a very wise man. But I would also say, if you give up hope, even if you're, and this is hope for 50 and 100 and 150 years from today, then you are actually abdicating some real deep moral responsibility for this, because I won't be around where most of this stuff hits the fan. But that's a physics colloquial expression. But seriously, you know, we are not going to be leaving our children and grandchildren a better world. And this is very serious. And so that's why we have to work very hard so we can get there. And as you say, to bend the curve. And we need to start bending in a couple of decades.
Do you see any exciting opportunities opening or inspiring action being taken?
Oh, definitely. I think we're living in it's a very important tipping point we are in right now, that the world is, will we be tipping back towards status quo, or will we decisively tip towards a transformation where we will bend the curve, which was on its way to be bent, by the way, 2014 to 2016. I think we are in a place now where businesses are stepping up in a very significant way at scale. As I shared during my talk, it is even surprising to me that we have only over 50 countries in the world that has adopted a price on carbon. But behind that, there are over 700 companies, multinational, international companies, that have adopted a shadow price on carbon. So I think there is a sense of inevitability of a transition towards a decarbonized future. It's just a question, will we do it fast enough? And I think that is quite promising. I think that when Volkswagen just last week announced publicly that it sees an end date on the combustion engine, saying that we'll sell no more combustion engine cars from 2040, a bit late-ish, but it's significant. It's of course a reaction on a deep crisis, but it tells you that we have really reached the beginning of the end of the fossil fuel era. And what we know, which is Stephen's point, which is so important, is that we're coming to this beginning of the end not based on an environmental problem, but based on an innovation pathway, which means that we see more and more evidence that this can actually be a self-propelling exercise, just like the Moore's law, basically, because we can make money along the way and we can have better outcomes for society. So I think there is hope in that sense. The question is just, will we be able to scale?
Julian, where do you see hope?
And I think education is just such an important thing. And my observation, having taught students for 40-odd years, is that the students who are coming through today are very much more aware than previous generations of the problems that there are, and actually are demonstrating a very strong willingness to address those problems. And I think younger people are, in a way, our hope in part, because they carry the message.
Yeah, I think today we see really kids stepping up
Yes.
and demanding a future,
Yes.
basically, from us. I wanted to give the opportunity to also to the audience who've come all the way here to listen to us, to ask questions to this panel. So if you want to ask a question, raise your hand and there will be a mic coming. Here we have one. And it's important that you wait for the mic so that our viewers can hear what you're saying.
Are you personally doing something against like climate change? So are you climate compensating your flights, or are you eating vegetarian? What are you doing as a person?
Well,
Thank you.
I fly all around the world talking about climate change. The irony has not escaped me. But I drive 1,200 miles a year. I ride my bicycle twice as many miles as I drive a car. We're on the bottom rung of, my wife and I, in terms of electricity use in California. And so we're eating less and less meat, for sure.
It's difficult to get to the polar regions without using ships and aircraft, I'm afraid. And I suppose, you know, the reason we do it is because we think it's important enough to try and understand change, and indeed, importantly, the rates of change that are going on in those places, that we think that matters enough that I suppose we make that sacrifice of getting there in the ships and aircraft, because there really is no other way to do it.
No, I mean, that's a very good question, and myself and my family, we also do as much as we can, but recognizing that it's very challenging. We try to operate as much as we can along a carbon law to try and cut our emissions by half, and that has proven in the beginning to be quite easy, actually. We have not 2 cars, only 1 car. It's a biogas car, a very small car. I go cycling and everything. I use only public transport, no other means of transport. You know, pulling down very significantly, not only on meat actually, but not throwing food whatsoever. Trying to, you know, go on vacation in Sweden instead of going elsewhere, using train as much as possible, but still recognizing that, my teenager just said hello from Verbier, where he is right now as a ski teacher, and you know that was through aircraft. So it is a struggle all the way, but I think we can do a lot. But I always try to answer that question by saying that the number one task for us is not to get depressed and saying that we should load all the responsibility on your shoulders or my shoulders. This is a societal transformation. And we need to also talk about this, share the knowledge, have our ears on the ground on the science, and quite frankly, make our voices heard as much as possible so that democratic processes can really move on the societal transition. So it becomes easier for us to live in a decarbonized modern world. So it goes both ways.
And it's really also about expanding your identity from being a consumer to being a citizen, I think, and an activist. And there are so many ways that you can influence this transformation beyond your lifestyle choices, although they are, of course, very important, and you can make a big impact through your lifestyle choices. You can make an even bigger impact through your conversations, where you work and what you decide to put your energy on, and how you vote, and things like that. So, but thanks for a great question. We can have one more question. And then there was one over there that I saw first. If you can get to the gentleman. I think keep your hand raised, yes, you, so that the mic can find you. That's cooperation. No one is grabbing the mic and taking the chance. Thank you.
Thank you. How important is population control in reaching the carbon targets that we're seeking?
Population control, how important is that? Maybe for water and climate.
Well, it's essential. We're 7.5 going to 9-ish, 9.5 mid-century. The good news is as people grow wealthier, they have fewer kids. And so actually if you accelerate wealth creation in developing countries, you have to bend that curve. And you have to bend it, and then the economists have to think of economic models which is not dependent on business growth because their whole model is you just consume more, you make more, you do more stuff. And this is not a sustainable model, clearly, but yet there's no economist willing to say, no, we've got to get it so that you can actually have a higher standard of living with a shrinking population. So, but it's very real. With more education, especially with women, you have smaller families, and then everybody says, no, but you need at least 2 kids. No, it's okay to go back to 5 billion or 8 billion.
You know, I agree with Stephen, but I also agree with our great hero, late colleague Hans Rosling, who reminds us every time that we have bent on the transition curve with regards to demographics already. So even though population continues growing, we have actually started the decline in fertility per adult woman in the world. However, over the next 30 years, it's very difficult to change the pattern because these are very slow variables. And we know that it's over the next 10, 20 years that will determine whether or not we will be decisively moving towards a decarbonized future. So I think we have to remind ourselves all the time that we in the rich world are emitting, roughly 5 tons per capita per year on domestic emissions, but roughly 10 per capita if we include consumption. And that is 10 times more than the African average. So of course, it has to be recognized all the time that the rich per capita emissions are those that need to go down fastest, even though population is really important. And in the immediate, it's very difficult to change the curve. But of course, we have to do everything we can to avoid that Africa becomes, what can it be, 3-4 billion people almost, instead of, its projections. I mean, the low-high projections are just the difference between manageable and unmanageable.
But it is distressing that the developed countries are now encouraging their, quote, native populations to have higher fertility. Yeah. And this is so I go back to, no, we need a different model than that.
Yeah, that's important.
Thank you. We have a few minutes left, and I would like to just speak a bit about the role of science, because I think you've all stepped out a bit of the conventional way of doing science in your endeavor, and I think sparked by your realization of how severe these issues are, that you're scared to death, and that moves you, I think, to do science a bit differently maybe than you did, than is normally done. So can you speak a bit about that, the future role of science in contributing to addressing these challenges?
I mean, concerning the polar regions, I'm still very much a practicing scientist, and what I shall be doing next is going out on an icebreaker to Antarctica in about 3 weeks' time to study exactly one of the problems that Stephen mentioned first and I mentioned too. That is to say, how stable are these floating ice shelves which are buttressing much of the ice on the interior of Antarctica and are one of the most major unknowns, but one of the most important potential factors concerning sea level rise, both its absolute magnitude and its rate of rise over the next 50 to 200 years. So we shall be using autonomous underwater vehicles to look into probably the least known places on planet Earth, the immense cavities beneath hundreds of meters of ice at the periphery of Antarctica, to try and work out various parameters such as roughness and turbulence to input to the numerical models, which will help us to understand better how stable these features are on timescales of decades. So that, if you like, is practicing science, yes. And it feeds into the points that you two are making, I think, but it's a small part of your whole.
And it's really about closing those knowledge gaps that we still have about how the planet operates and how these glaciers actually work.
And I think there are certain things that are particularly important that we don't know about at the moment, and that buttressing effect and the stability, the resilience of ice shelves is one of the critical parameters, because it fundamentally affects whether we're talking about less than a metre of sea level rise, and maybe 2 or 2.5 on the timescale of a couple hundred years. So this is serious stuff. It's a particular kind of science, but it does matter.
Yes.
Yeah, and I would add that I also do most of the lion's share of my time is actually doing what you would call traditional science, but it's gone into other things because of the energy climate issues, I'm trying to make better batteries. We would like to make a battery that has 4 times higher energy density, but 4 times faster charging, so that you can get a 150-mile range out of a total of 300 miles in 5 minutes, 6 minutes. When you get that, the game is over. Personal vehicles go to electrification, which gets much cleaner. And electrochemistry, I also do biology research and biomedical research. And only in my spare time do I actually worry about water and climate and things like that. But, so it's like the first 70 hours goes to science. The next 30 I can lavish on other things. And my goal about keeping a carbon footprint is, as my wife knows, I don't take vacations.
Isn't it also so, though, that you did shift your research focus a bit?
Yes.
And you've encouraged others to
Yes.
do the same, given the challenges that we face. We all need to put our energy where it matters.
Right, especially if you can get these newer people, that their ingenuity and things will give us even better choices that will accelerate what we need, where we need to go.
And Johan, what will be your next big step in your research?
Yeah, I almost forgot my line here because I thought that taking no vacations, I might consider. What about no eating then? That might be another very effective
science
strategy.
shows that you live longer until you starve to death. No, seriously, actually, a starvation diet means you do live longer, but you don't overeat.
No, jokes aside, I mean, one fundamental research task at the Potsdam Institute, with very close collaboration with Stockholm Resilience Centre, is of course to dig even deeper into understanding Earth resilience and at what temperature rise are we really at risk of passing thresholds that irreversibly would change the feedback dynamics and cross tipping points. I mean, that's, I think, a very important task for the interdisciplinary Earth system science. But equally important is the big quest of answering the following question: what are the social tipping points that can unleash large-scale disruptive changes in a desirable direction? What lessons can we learn from history, and what can we do in the future to really ramp up disruptive change in the digital world we live in? So that's a second strand of research. And then finally, where I think we connect very closely is, big data, machine learning, and artificial intelligence is entering the stage of Earth system research and global sustainability in a very fast pace. And soon we'll have the ability, to use supercomputers to really understand the dynamics in both the Arctic and Antarctica with human behaviors across scales that we've never dreamed of in the past. So we're putting quite a big investment actually right now in artificial intelligence for Earth system research, which is one of these frontier areas where we quite frankly don't know where we're heading, but it would be very interesting to, if any one of you are interested in that, let's follow up on this.
So I would say that to be scared to death, I think you sound very excited also, and I do think that the science has that feature, that it is very interesting times, and it is about really understanding our future. And I would like to end just with quoting Greta Thunberg, this 15-year-old who is now really an activist who's making politicians across the globe listen to kids. And she says that hope is important, but hope really comes from action. Action is more important, because from action comes hope. And I think that's a good ending of this panel. Thank you so much for your time, and thank you.
Thank you.